Okay, so run that back really quick. When we multiply this, we're going to get x to the third, 3x, negative 7x squared, minus 21. We're going to take everything, write it out. And then if we can simplify anything, we will. But in this case, we can't. Okay. So you're going to title this page, Finding the Zeros of the Function. Finding the zeros of a function. Finding the zeros. Okay. So how many zeros does f of x have? And then how do you know? So go ahead and write down example 1. You'll write down this equation. Now, this is a little different from what we've seen in the past. This has 4 terms in it instead of 3. Okay, so it's a little bit different, but we can still do it kind of similar. I'm going to show you 2 different ways to do this today. Now, when we have 4 terms, we're going to go ahead and put them in the box. Okay, so watch what happens. I put that x to the third in this first box, negative 2x squared in the second, negative 9x here, and 18 down here. So I just put each term in one of the boxes.
Like working backwards?
Yes. Your biggest term or your first term has to go in this first box, and the last term has to go in this last box, but these 2 could be either. Yeah. So now what you're going to do is take out the greatest common factor. Okay, so from this column, what can I take out the greatest common factor? X squared. Oop, that's cute. X squared. From this column, what can I take out? Is it going to be positive or negative? Negative 9. From this row, what can we take out? An x. And then from this row, what can we take out? Is it positive or negative? Okay. And you can always check by multiplying it back out, making sure each box is filled in correctly. So we have x minus 2 and x squared minus 9. Okay. Okay, what can we break it down to?
X squared minus 2, x minus 3, x plus 2.
Okay, so, okay, you were telling me the whole thing. X minus 2 times x plus 3 times x minus 3. Okay, this is a difference of squares. Difference of squares. Okay. So now what are the zeros? How would we solve for these? We learned about that yesterday. Right, so you can set them equal to 0 or just change the sign, right? So that's going to give me x equals 2, x equals negative 3, and then x equals 3. Ta-da! Okay, so how many zeros did we have? We had 3. And doesn't that check out with what we learned about yesterday? Look at our exponent. It's a degree of 3. We got 3 zeros. Ta-da! Okay, so now we're going to draw the sketch. The same problem, we're just going to draw the sketch. Okay, so what were my zeros? Tell me again.
Negative 3 and positive.
You're yelling. Okay, so we got 3, 2, and negative 3. Look at those awesome lines. Okay, now we see that this is an x to the third. That means it's going to look like this little squiggle line, right? That means I'm going to start down here, going up, down, back up. Okay, if you're ever unsure of the sketch of the graph, just plug this bad boy into Desmos. Yeah, go ahead. You can do it that way. Now, how many of these are real? All of them, all 3. How many are imaginary? None. Remember, your imaginary solutions do not show up on the x-axis. So that's the only downside to plotting it. If you plot it, you're only going to be able to see the real ones. Imaginary ones you have to actually solve for.
What if,
Yeah.
like, if you know, like, how many zeros you should have,
Mhm.
you bought it, like, say, for example, three, you know what it is.
You know, one of them is going to have a bounce, which we're going to talk about kind of coming up. You remember the duplicates? That can happen, but you can tell from the graph. We're going to talk about that in just a second. But like, let's say, for instance, you graph it has an exponent of 3. We know that those are all 3, and there's no imaginary. Okay. Go ahead and take a second. Write this one out. This is example 2. I want you to try the little area model thing. Okay, so I want you to actually like factor using the little box. Look at that box, killing it. Let's check yourself. All right, so we're gonna take this x to the third, put it there, negative 3x squared, put it there, and it's okay if you have those flop, that's fine, you should get the same answer. I'm gonna take out the greatest common factor, which is gonna give me x squared. From this one, it's gonna be 11. From this one, we're gonna get x. This last one, we're gonna get negative 3. So we've got x squared plus 11, and then x minus 3. Question, can you break down that x squared plus 11?
No.
It's a perfect square sum, but it's, okay, I'm sorry. It's not a perfect square sum because it doesn't have a perfect square. Like 11 is not a perfect square. Does that make sense? Okay, so we still need to solve though. So we're gonna take each of these and we're gonna set them equal to 0. I'm gonna do this up at the top so my people in the back can actually see. I'm gonna take x squared plus 11 and set it equal to 0. And x minus 3 and set it equal to 0. Now, when you solve this x minus 3, you're just gonna change the sign. X equals 3. Y'all probably got that. On this other one, we're gonna subtract 11. And then we're gonna take the square root. What do we know about taking the square root of a negative number? Imaginary, so we're gonna pull out an I, right? We have a positive and negative I square root of 11 as well. So how many real solutions do we have? And how many complex? 2. Complex come in pairs. There's a positive and a negative. Okay.
Wait, do that again.
The solving part. Okay, so we subtracted 11 with the square root. When we take the square root of a negative number, we're gonna pull out an I. Look at my cute little I. There it is. And then we have square root of 11. And then we always have a positive and a negative version. So complex numbers always have pairs. Okay. You won't have one complex answer. You have to have 2. Okay. Now, I'm going to show you the way that I learned how to do this back when I was in high school. This is called factoring by grouping. I think it's faster. It's probably similar to something you've seen in the past. I think you saw this back in like middle school. So what you're going to do is you're going to rewrite your expression. And you're going to put parentheses around the first 2 things and the last 2 things. Now, from this first group, what can you take out? Okay. And when we divide x cubed by x squared, what do we get? And if we take negative 3x squared and divide it by x squared, what do we get? Negative 3, right? Negative 3. Yeah. Okay. And then we look at the second group. What can we take out from this? Okay. And then if we take 11x and divide it by x, what do we get? It's just x, right? If we take negative 33 and divide it by 11, what do we get? Negative 3. Notice how these 2 things are the same. We're going to drop this one right here, push these 2 things together. So we're going to get x squared plus 11, and then bring down that x minus 3. That's the way I learned how to factor by grouping. It's the same thing as what you did over here. This is just a little bit more boxy. Ready? Oh, never mind. Okay, so we're gonna use the area model. I feel like that's probably what you did, right? You did both. Overachiever. That's okay. All right, we got x to the third negative ax squared minus 25x and then 25a. Okay, so we're gonna take out the greatest common factor. It helps me when I used to do this stuff. You want to cover up like the other column that you're not talking about. Okay, so for instance, we're gonna look at this column first. And so we're gonna take out the greatest common factor, which is x squared. This column is gonna be a negative 25. This row is gonna be x. This row, negative a. So we end up with x squared minus 25 times x minus a. Can you break down that x squared minus 25? Yeah, so what?
X plus 5, X minus 5.
What are my zeros?
5, negative 5, and negative 3.
5, negative 5, and a. And check those signs on that, because a lot of people mess up on the signs, and that's what gets them the wrong answer. Remember, you got to switch the sign. Make sure that you're good on it. So we've got x to the third minus 8x squared minus 25x plus 25a. We're going to put parentheses around the first two things and the last two things. From the first group, we're going to take out an x squared. When we divide this all by x squared, we're going to get x minus a. Over here, we're going to do the same thing. We're going to take out the biggest perfect square, the greatest common factor, which is going to be negative 25. And we're left with x minus a. Since these repeat, we're going to cancel this guy out, and we're left with x squared minus 25 times x minus a. If these didn't repeat, then this can't be factored by grouping. Okay, so if you don't get the exact same thing here and here, then they can't be factored by grouping. Okay, so let's walk through it. Okay, so she wrote out the problem, so it started off well. Okay, then we group, right? What'd you take out of here? X squared, and then she's left with x plus 3. Okay, so this part's right. Over here, we take out a 2, and we're left with x plus 3. Okay, so the second row is right. Now from the second row to the third row, what did she not do?
Yeah, and that's a true positive. I think it's supposed to be X plus 3 and X minus 2. Like how
Okay, so let's try it this way. Let's say what we don't want to do it the algorithm way. Let's do the box. Okay, so if we did it this way and we factored, I'm gonna do this quickly so you can see it. What's the difference between this and that? She's got an extra x plus 3. So she didn't drop this guy. So she can smush them together. Yeah. Well, and then another thing, in order to check this stuff, what you can look at is if you took just the x terms and multiplied them out, that would give you x to the 4th, right? Well, what did we start with? So something wasn't right there either. Yeah, so she had too many x plus 3. Yay, go math. Okay, so let's try by grouping, and then you can check it using the area model. So I'm going to group the first two. What can I take out from these two? X squared. If I take x cubed divided by x squared, what am I left with? Okay, and then plus 6, right? From over here, we can take out a negative 3. And then what are we left with? So we got x plus 6, right? Because we're dividing by negative 3. Be careful of those signs. Now, since these are the same, we're going to drop one. And it's going to give me x squared minus 3 times x plus 6. Can I simplify this anymore? No, so that's my final answer. Yay! So checking your work, you should have gotten x squared plus 5 and then 8x minus 3. Okay.